Good morning. My name is Ian Poyner and I am from the IoT Security Foundation, and today I will be talking about the Many Secure Gateway project and how you can get involved. But firstly, many thanks to Professor Mark Beach, Anita and the team for arranging this conference, and just as importantly, thank you to all the contributors and audience for a great first 2 days. The slides are available and I have included a list of references at the end. So, a short introduction to the IoTSF and our impact. The IoTSF was established at a conference at Bletchley Park 6 years ago yesterday as a not-for-profit organisation where industry, academia and other SMEs can collectively make a valuable contribution to improving IoT security. We were consulted by the Department for Digital Culture, Media and Sport when they're developing the Secure by Design and also the UK's Code of Practice for Consumer IoT Security and the draft legislation which is currently going through Parliament. And significantly, the DCMS Code of Practice is the basis of ETSI 303645 standard for consumer cybersecurity, which is gaining widespread adoption globally as part of national certification schemes in Singapore, Finland, Vietnam, and most recently India, as well as many industry schemes as well. Our compliance framework, which is free to download by the way, is also cited in the US NIST guidance. So if you really want to make a difference, then you're welcome to become a member and contribute to our working groups with the added benefit of being able to join the longest established IoT conference in November. And these are some of the people that we work with and who contribute to working groups and publications. So a key message, as one of our members put it, is that if it isn't secure, then it isn't smart, which we all need to keep in mind, I think. Right, so what is the Many Secure project? Firstly, the name is intended to highlight how this is very much a collaborative project, collaboration across many stakeholders for the wider benefit of many users. The project is supported by Innovate UK with 4 core members, plus very active involvement from across the IoTSF membership, contributing to the Many Secured Special Interest Group, including Warwick and Birmingham City Universities, BT, IOE Tech, Signify, plus several independent expert professional members. And we're all familiar with many definitions of IoT. Almost every specification or regulation seems to have its own nuances. And sometimes smart devices may include smartphones and laptops, but for this presentation I'll concentrate on more constrained devices. This audience will be familiar with the characteristics of IoT devices and IoT networks, which can introduce security vulnerabilities, particularly with constrained devices, often working from a battery with limited processing power and no secure boot or storage. But an important point is that however we try and improve security going forward, then any solution also has to work with the billions of devices already fielded, which may remain in service for a decade or more, and also any new device that has weak security. In the interest of time for this informed audience, to summarize the issue with constrained endpoint devices, there's much lower trust in their physical and digital security because there are far fewer resources to verify and authenticate messages. Analogous, I like to think, to a user doing online banking without checking for the HTTPS padlock in their browser. The impact of the weaker security is not only on these devices and their associated data and actuators vulnerable themselves, and just consider the horrific case of your locks or lighting system being hacked or a production facility being made unsafe, but because these devices can be your weakest link, they're often targeted to be a point of ingress to the wider corporate network or for exfiltrating data, such as what happened with the Target HVAC hack or the Smart Aquarium thermometer, which egressed 10 gigabytes of data from a Las Vegas casino. So this is a simplified overview of the Many-Secure project and how we're tackling IoT security by placing the gateway at the heart of the data flows. The project has identified that the router, or the gateway, provides a great vantage point to monitor and control a network, particularly regarding any anomalous behaviors by a constrained device. We have chosen to concentrate at the router gateway level because often it is a more capable device. It's mains powered with full connectivity, potentially with more processing power. It has most of the external traffic flows go in and out through the router, with the exceptions of possibly LoRaWAN, Sigfox, narrowband IoT, LTM, LTEM, and GMS connections. But routers are still price sensitive because ISPs have to effectively offer them for free. I mean, there's exceptions where people buy their own high-end router either for speed or for wider coverage. We're pushing to make the case that a secure gateway can be a distinct marketing point for an ISP, and we have major telcos contributing to the project on that basis, which in turn will help drive manufacturers to create more secure routers and gateways. In the immediate next 6 months, we'll be addressing what the foundational or hygiene security standards that gateway needs to comply with. I would be very interested to talk with anybody in this audience who wants to contribute to this. In the longer term, there will be advanced requirements to incorporate the many secured features and schema that we are currently developing. So the SUIB, or the Secure Usable Intranet Browser, is required for bootstrapping, by which I mean the onboarding of a device to a network securely, which is much more difficult than the general user appreciates, which we'll discuss later on. Suffice to say at this point that bootstrapping and any ongoing device management is often completed securely over HTTP rather than HTTPS, or relies on the device manufacturer writing and maintaining an app and the user needing to have yet another app on their phone or tablet to manage devices, to the extent that some people may need 3 or 4 different apps on their phones simply to manage light bulbs from different manufacturers. D3, or the Distributed Device Descriptor, includes both a local and a collaborative repository. Is all about understanding what type of device is on the network and its qualities. The granularity of this device type may vary from something like a generic printer all the way down to a specific firmware version. You could consider this to be a type of taxonomy, but we have deliberately avoided trying to attempt to reach agreement amongst all the manufacturers and stakeholders. D3 allows manufacturers, organizations, and other interested individuals to make assertions about the device type and its expected functionality. This is similar to MUD, or the manufacturer usage description described in RFC 8520, but allows for a wider community to make different assertions to that of the manufacturer. And one reason why we chose to do this, because potentially it survives longer than a manufacturer's support period, or if the manufacturer goes out of business. We've already seen instances of expensive smart homes effectively being bricked because the manufacturer has closed its ecosystem. D3 would need to be hosted in an open repository or data lake, and one of the challenges is how to assign weights to the trust assigned for each assertion. D3 in turn enables the local monitoring and control by the local intelligent agents that determine whether traffic flows are abnormal. For example, a toaster communicating with door locks, or in an industrial setting, a HVAC sensor communicating with centrifuges or production plant. One note is that this functionality has to continue to work when there is no external internet connection, either because of deliberate security lockdown or due to an outage. Nobody wants their thermostat to stop working or production to be halted every time that the internet connection is lost. Training the monitoring and control algorithms artificial intelligence, machine learning, will require a lot of data from a very wide variety and diverse user environments. A challenge in the short term is how to collect sufficient data to develop these models without creating privacy issues for the contributors. In the longer term, it is possible that a variety of companies will offer their own proprietary control models as a service to users and organizations, but following the the many secured schema. So a bit more about the secure usable intranet browser. Everybody uses a browser. Our browser is always chosen, or mainly chosen for the onboarding of devices because it's ubiquitous. But almost invariably, as I said earlier, it uses HTTP, not HTTPS. Next time you try and log into as a local admin into your router, or to onboard a new thermostat or light bulb, you'll probably be asked to enter 192.168.0. something. As you can see from the diagram, the padlock is often struck through, showing that it's an insecure connection, and because there's no certificate, there's no encryption, and that's why the padlock's not showing. Now, this seems bizarre that we do this using the most insecure method, but there is a reason for that, and it comes down to the Certification Authority Browser Forum. They actually write requirements, and their requirement 7.1.4.2.1 actually prohibits certification authorities from issuing a certificate for an internal name. So it's actually insecure by design. So you can read the more greater detail about this in our white paper, which we released in last August. So there are potential solutions which we're working very actively within the team to develop at the moment. But the one thing it has to do is be usable by the general public. You may be able to read in that little browser, a picture of the browser, is that your connection is not private, and hackers may be trying to attempt to steal your credentials. So that's really important for and really appropriate for when people are connecting to things on the internet, the Wild West. But we could probably go back to the certification authorities browser forum and maybe advise them or get them to provide different warnings or advice for intranet connections. But that will take years. It could take at least a couple of years. Could use an app, and this is commonly used, where a manufacturer you download an app onto your phone or your tablet, and that the manufacturer writes the app to work around this insecure connection warning. But unfortunately, it's not very scalable because the manufacturer has to produce an app for each device type, and the user has to install yet another app for every manufacturer. And also there's a more fundamental problem in that there's a duopoly of the app stores between Google and Apple, and they control the distribution of the apps, and commercially they want to establish their own ecosystems ahead of any new incoming member of the market, player in the market. And so you have this tension where they control the distribution of competitors' apps, which goes against all internet principles. And probably most importantly, a new app increases the attack surface, and you may actually be doing more harm than good. You could also install a new root certificate, and large enterprises do this, but it's not practical for most consumers and SMEs, and it's potentially yet another attack vector. So to learn more about IoT security in general, go to the IoTSF Security Foundation, look at our videos, YouTube channel, and we've also got a couple of really good white papers and problem statements on the Many Secure project. These are the references, and I invite you to actually join the Many Secured Special Interest Group, and now I'll take questions. Thank you.
Well, thanks very much, Ian. Most interesting. So if I can encourage our audience to use the Q&A box to pop some questions in. If I can kick off, Ian. So right at the beginning, you made, gave this lovely example of the DCMS code of practice, finding its way to become an ETSI standard. How long did it take to get it through ETSI?
I think, well, it was about 2018 when DCMS went out, published a code of practice, and the ETSI standard came in, was it earlier this year, late last year. So effectively about 2 years, between DCMS publishing their code of practice and the ETSI standard becoming authoritative. Before that, there was a tech standard 103645, which is like the working standard, which was close to the actual final standard. And I think that came in about 2019, 2020, so it's quite quick. I think a lot of the work that DCMS were doing was also, ETSI were also mirroring it in parallel as well. But in terms of actually getting ratification of a standard into a European norm in EN is quite quick, because, as I said, the technical spec, which is the working document that gets you to EN after full ratification, that was fairly mature after probably about 18 months, 2 years. But it precedes my time on the project, so I'm not very familiar with the actual timeline aspects of it.
Yeah, really good to hear, and really good for the UK.
Yes, yes.
So you've got very diverse membership, and your members will have their own interests, their commercial benefits and know-how. So how easy is it to get consensus of opinion so you can actually drive through change?
Yeah, that's a fundamental point in terms of at the working level, at the technical level. We have people from competing ISPs and competing organisations who are working very closely together. It's quite illuminating that you've got these major corporations, and what's driving them is the social responsibility. And I think a lot of the engineers and the project managers on the project actually feel that they need to do this. In fact, one of the project managers from the major telco said, we need to do this. She was encouraging the rest of her team, don't drag their feet. They need to actually get behind this initiative. And I think that where we will see it is where we go to ratification, and where the lawyers and where the commercial interest will come involved. It's quite interesting that the Certification Authority Browser Forum, they were deadlocked or gridlocked on one particular aspect of, I think it was the expiry of the certificates. I think at that stage, the certificates, you could still get them so that they never expired, 100 years expiry date. And then some people wanted to bring it down to 3 years. I think in the end, it was Apple who said, no, we want to bring it down to 12 months. And this went around in gridlock in for about two years, trying to get ratification. And in the end, Apple just made the statement that we'll do it. We're going to put a maximum expiry of certificates on 18 months. And now I think they've brought it down to 12 months. And that was because they've got the market share. They could drive this because it was good. Not for their business, but it's good for security, which is what they major on. So, yeah, I think there's a lot of commercial tensions between different corporations or organizations. But I think when it comes down to security, none of them want to be left behind. So that's, the social responsibility is fortunately becoming a major issue at board level.
Okay, well, thank you very much. We now need to move on to the next presentation. So thanks, Ian.